Hi, ladies and gentlemen. I just wanted to put up a quick video going through slides 16 and 17 from lesson number 10. So here we go. Let's take a look first at slide number 16, where it said we had to simplify each expression. Simplify each expression using the rules of exponents. If you get stuck, look back at it's 14 and 15 here. So let's take a look at this first one here. So if we look back at our slides, if we look back at slide number 15, it actually says that when we have a number to a 0 power here. So when we look back at our slides and we say to ourselves, oh geez, look at that. This guy here talks specifically about raising to a power of 0 exponent, right? So what we need to do is we need to read the rule. It says rule, any term raised to the 0 power is equal to 1. So if I come back to my slide here, I'm going to know that, I have a raised to a power of 0. So that means my answer is going to be 1. Remember, do you see how I referred back to that slide to help me? That's what you need to do here, okay? So when we have this next one here, we have, oh gosh, that's a negative exponent. I can't remember exactly what that rule is. So if I look back at my slides, and, oh my goodness, look, a negative exponent right here. Crazy. What we need to do is read this rule. Raising a power to a negative exponent. The rule is to take the inverse, or we know this as the flip of the positive exponent solution. So we gave an example here. 7 to the negative 2 power is equal to 1 over 7 to the second power, which is equal to 1/4. So if I come back to my page over here, I can rewrite this as 2 to the negative 5th. I rewrite this as we said, we had to flip our fraction, so it's going to be 1 over, and our positive exponent, so it's going to be 2 to the 5th power. When we type that into our calculator, we get the number 1 over 32. Okay? So now we have 3 to the second times 3, right? And so we need to first, before we even answer this and look back at our rules, we need to remember that if we have 3 just by itself, we can imply that it's 3 to the first power. So, look at that. I'm multiplying exponents here with the same base. So if I look back at my slide number 14, multiplying powers with the same base, add the exponents and keep the base. So I need to come back here. If I have 2 to the 5th times 2 to the 3rd, I add the 5 and the 3, and it combines to 2 to the 8th. If I come back to this slide right here, I need to say to myself, I have my base of 3, it stays the same, and I have to add my exponents, so it's going to be 2 plus 1 gets me a 3, which when I type that into my calculator, which is down here below, I get the number 27. Okay? Nice job there, my friends. So now, this one's similar, but a little bit different. I have a power to a power. So let me go back to my slides and check out what I have to do when I have a power to a power. Slide 14 has raising a power to another power. We need to multiply the exponents and keep the base. So if I have a to the second times to the 5th power, I have to say it's going to be a base of a still, and I have to multiply my 2 times 5 to get a to the 10th. So if I come back here and I go through that guy again, I say to myself, what is 2 to the second power? So I have to multiply my 2 times my 4. My base is going to stay the same. It's going to stay as a 2. And now I need to multiply my two numbers here, and I'm going to say 2 times 4 is 8. Okay, nice job. Let's take a look at this last one here. I have 5 to the 7th divided by 5 to the 3rd. What we need to do for this one is we need to look back at our slides and see what our rule is when we divide. So when we have to divide powers with the same base, the rule is subtract the exponents and keep the base. So if I come here, I have keep my base. It told me to keep my base, so my base is going to be still a 5. And I have to subtract my exponent numbers. 7 minus 3, it gets me a 4. Okay, so ladies and gentlemen, that's how we go through and complete slide number 16 on our activity that we have for today. If we now take a look at slide number 17, let's take a look. Everything we need for that one is going to be all in that same slide. Okay, so if we look here, we have, 5 to the 0 power. 5 to the 0 power, and remember, if I'm thinking back, also, if I'm looking at this table right here, the 0 rule, raising to the 0, it's always going to be 1. So I can right away say, oh geez, I know that's going to be 1. And I can say to myself, do I have any other numbers here that are raised to the 0 power? Ooh, look at this guy's here, raised to the 0 power. So I can say also that his value is going to be 1 as well. Okay, got that one done. Now let's take a look at question number 2. Okay, so I have a 3 to the negative 2. Let's see if any of these rules talk about negative. A negative exponent rule. When I have a negative exponent, take the reciprocal of the base and the exponent. Always get rid of the negative exponent in the expression. So that means if I have an x to the negative 2, I write it as a fraction over 1. And then I make my exponent positive again. So it would be 1 over 3 to the second. And then you would say caret, and then you would write a 2. Nice. Okay. Do I have any others that look like this? Have fractions with a denominator of 1 and a denominator of an exponent. Oh, these guys right here. But they're sort of written, oh my goodness. So I'm going to have to go backwards here. So I have to take these fractions with exponents in the base, and I have to turn them back to negative exponents. So if I have 1 over 20 to the second power, I know my base here is going to stay the same. So it's going to stay at 20. And it's going to have a base of the same number, but it's going to have to be negative. Okay, I'm not going to do this bottom one down here. I want you guys to try that one based on the example that I just did right here. Equal to 1. And let's take a look at this last one here. Okay, so when we take a look at this last one here, we have 6 to the first power. And we said, it's to the first power. And if we look to the ones rule, a number raised to 1 is always that number. So that means a 6 raised to a 1 is equal to a 6. So a 4 raised to a 4 raised is going to be a 6. So now if we take a look at this one here, 1 raised to any number is always 1. So if we have a 1 raised to a 4, it's going to be equal to a 1. And this guy here, if we didn't get this one here, you're going to work on that one independently. So ladies and gentlemen, this was slide number 17 on lesson number 10.